come to order. Thank you. We are going to have an abbreviated business meeting because we've got two speakers tonight, Bruce Powers and our special speaker, Rich Roberts, who's going to talk to us about T Corona Borealis, the star that's due to go nova any day now. And first of all, did everybody get a ticket, a raffle ticket, or a door prize ticket? Yeah. Okay, good, because we've got some good door prizes tonight. Let me write that down, make sure I don't forget it. Door prizes. Okay, first report will be our vice president. Oh, before we start, I got on the screen for those of you out in Zoom land, Corona Borealis, Northern Crown, which is right near Boötes and Arcturus, and the share the screen. I did share the screen. Oh, good. Can you see it, Rich?
I can see it.
Yeah. Okay. So, in order to find T Corona Borealis, you can go into Stellarium, do a search for TCRB, and it will find it. And then you can zoom in on it and see how to find it. You can see those stars. I think it's Eta. Corona Borealis is right there on the corner there. And just keep zooming in. Follow those, Epsilon, that's right. Follow that chain of stars. And there's a little star, not very obvious, but it's also called the Blaze star. And it's a cataclysmic variable star and a double star. So anyway, that's just for fun.
It's very near IC 4587.
Wherever that is.
It's right next to it.
Okay. All right. Anyway, I just thought I'd share that for fun. And how do I get out of this? How do I stop sharing?
I think I can stop you.
Okay. All right. So first report is our vice president telling us what's coming up on schedule.
Maybe I can't.
Could you just click OK?
You got to share anyway. Jeff's going to share Nice Guy Network.
That's right.
Go ahead.
Very good. Thank you. Thank you. All right. Let's see. Close that and open mine. We open mine first so we can do it. Now, let's see. Where is it?
You do need to reshare.
I will. Oh, I had it. I had it. I had it. Looks like somebody took it off. I had it. I got to log in again, I think. Wait a minute. Is that it? One of these things? No. No, it's on this one.
The other browser?
No, it's in Chrome. Oh, I'm still logged in. That's good. I'm good. I'm good. All right. Now let me see if I can let me share it again. Okay. All right, let's see.
No. Go to my club. There you go. So you use my club. There you go.
I got it. Okay. Welcome, everyone. We have our club meeting right now. Everybody knows that. Corn Watch tomorrow night, Night Watch, and York River State Park is Saturday, and Great Navy Camp Out may be rained out, but we have Jeff Edmondson to give us some. He's going. So I don't think so, Lucy. But anyway, I hope we have Great Navy Camp Out on Saturday. It's at the Breezy Point, and if you don't have a pass, we'll have to come pick you up, from the main gate, leave your car there someplace. We'll get you. Just be sure to RSVP if you're coming to the Great Navy Camp Out. It might rain though, but we'll see. The next event is Boardwalk Astronomy number 5. at the 24th Street bandstand, and they cut the lights out. And it's great. It's a great event. If you haven't been there, please do come on out. Even if you don't have a telescope, you can help us avoid the work the crowd, not avoid the crowd. we like the crowd. I think the last time we had about 200 people there. It was huge.
Supposed to be clear.
That's right. Yep. Jeff Edmondson says it's going to be clear on Tuesday. I just saw his forecast. Boardwalk Astronomy is at the Kempsville Rec Center is on Wednesday. Garden Star on Thursday. So big outreach every day, 10th, 11th, and 12th for everybody. Please do come and support this if you can. International Observe the Moon Night on the 14th. I don't have the perfect venue, except perhaps we can have it at the boardwalk. I've got a tentative yes from the honchos. They just haven't called me back to 100% confirm. But I talked to the assistant, and she said, I don't see any conflicts, so but we have to wait to get together with Mr. Hilton. All right, so we'll wait for that. Partial lunar eclipse is the next thing on the 17th in the evening, and I'd like to try to get a nice public venue for that. Either the boardwalk again, or maybe Tidewater Community College, and I'm springing it on Kevin for the first time. He didn't even know. Kevin's in here. He's in the audience, so we'll talk about that. So it hasn't been officially announced where, but we want to be able to observe the moon night and partial eclipse. I don't know. We could make it here if you want to do the partial eclipse thing here too. What time? It starts around 8 o'clock, I think. I got the times. The time for the eclipse. You mean?
Yeah.
Okay, I got it right here. I put all the times in. 8:40 we start the penumbral, and then the umbra starts at 10:12 to 10:44, and then the umbra goes away, and the penumbra is still there. You can see the penumbra photographically. I was surprised. I did it last year. Even if it's just a penumbral, penumbral eclipse, you can still see the dark part of the moon, and you don't notice it so much naked eye. So it's all over by 12:46. So think about that for where exactly. I'm tentatively saying it's going to be on the boardwalk because we probably could get more audience, I'm thinking.
8:40 p.m.
Yeah, this is all the PM. All this is PM.
Think about who's on the boardwalk at that time.
I don't know.
The drunk people.
The drunks? Okay, the drunks. All right, so all right.
Yeah, kid knows.
No, we've seen our share. If you haven't been to the Boardwalk Astronomy, it's a show. It's a show for them, and it's a show for us. Okay, it's really cool though. All right.
Yeah.
Kent's here for the first time in I don't know how long.
15 years.
15 years. So let's all welcome Kent. Let's all welcome Kent to okay, very good. And I heard a rumor that he's going to bring his 25 inches to the boardwalk, but no, I'm just kidding. I'm kidding. We all know that's not right. Yeah, I know. Okay. Let's see, back to this. Garden Stars, International Observe the Moon. Still waiting for the firm venue, and I'll put the message out for everybody to volunteer for that. Partial lunar eclipse is, like I said, the 17th, and this much of the 18th, not a whole lot. It's mostly the 17th in the evening, as we saw. Saturday, Sunday at Elizabeth River Park, 10 o'clock. Falls Cape Night Watch at 7 o'clock. And I understand there's a trail you have to walk and everything. And what we're going to have them do is they're going to put us in a little, I don't know, some kind of, was it?
It's a van.
It's a van? Okay.
Yeah,
And we can put all of our, okay, because your wife, right. And so we're gonna hopefully get a lot of volunteers for that. I've never been there. I'd like to see. Yeah, I want to see what the night sky looks like there too. Great. Okay, that's on the 21st. So Saturday, Sunday is going to be a big day if you do both.
Yeah.
We observe the sun at Elizabeth River Park and observe the stars at 7 p.m. Okay. Let's see. Where are we at? Corn Watch. 9 a.m. Mr. Farrell's estate sale. If you haven't heard, if you're not on the Back Bay, what is it? Back Bay IO, Group IO. There's an estate sale, and if you want to talk about that,
Yeah.
okay. So Kent,
So Barry Farrell was a friend of mine, and he was in the club for many years.
get closer so they can see you on
And,
camera.
He was a great guy, and he loved to collect equipment. Sean can tell you this because he'd come to the Chesapeake Planetarium with a bag every weekend. Just look what I got. And he passed away unexpectedly just before Christmas. And I was the first one to know it because I got a return Christmas card I sent him with stamped deceased.
Wow.
So anyway, his family contacted me and Robert Hitt, and we suggested, well, why don't we have an estate sale? Because they've been burdened with right much money, the family has. So I'm selling equipment really cheap, and most of it's pretty new. It's good shape. I can't guarantee any kind of warranty or anything like that, but you look it over. There's some Nagler eyepieces, Televue Delos eyepieces, Plusels, 3 telescopes, binoculars. Anyway, my backyard's going to be filled with equipment. Going to be on the 28th of September from 8 a.m. to 4 p.m.
Okay, this says 9. We make it 8. I'll change
No,
it
I'm
to
sorry,
8.
9 a.m.
Okay.
to 4 p.m. That's right. Thank you. And cash or check, if you write a check, make it to the estate of Barry Gene Farrell, and I'll have all that written out. And I have some sheets here with a short list of some of the equipment that Barry had that will be up for sale. So, yes, where is it? The address is on this envelope. It's in Virginia Beach. I'm in the Kempsville area, centrally located. My parking is very limited in my driveway. You'll see a house to the left of you. You can park there. And across Kempsville Road is a shopping center. So you may have to have that. Cinema Cafe used to be a Kmart, it's closed now, so there's ample parking there. So you might have to walk a block, because there's not much room. And I don't know if there's gonna be 2 people or 200. So anyway, that's the Barry Farrell estate sale. And,
Well, you only advertise it to the local astronomy club, so.
yeah, I've said that you really have to be you don't have to be in this club, but to take advantage of these low prices, you should be in an astronomy club. And it's definitely not a Facebook thing that I've posted for everybody. It's just going out to amateur astronomers.
It's a good deal. It's like a third of the cost of what it costs for it.
Yeah.
And then most of the stuff, well, Barry, he didn't use it. He would buy it, use it once, put
Please
it
don't
away.
finish up
Yeah.
quickly. Just don't
So
go
it's pretty-
think
a lot of
into
it's
the next
pretty-
month.
Always had the best.
Yeah.
The best of everything.
Yeah, so
Nikon
it's-
binoculars, overwork binoculars, Televue, Pentax XW, which is my favorite. Although I will say, for my 25-inch 16mm negative, if anybody's ever looked through my telescope for the past 25 years, that eyepiece is welded in the focus.
Right. Thank you,
So
Ken.
anyway, you have any questions, just let me know. There's
Thank you, Ken.
sheets here with my address and all that.
Okay, we got to move our thing here. We're just going to cover September
I'll put them up here.
because we got lots of things in the program today. Rain and Science outreach has not been approved 100%. That's going to be at ODU. I just saw it today for the first time, and so we'll take a look at that. So there's a couple of things: a Saturday morning at 9, and Saturday morning at 10. So you could go from one to the other. That's at ODU. There's also 4 more events. I didn't realize there was. So let's see if we can check those.
I think there's 4 total.
Oh, 4 total. Okay. All right, I got you.
So Skywatch and North Rivers.
Right. Okay, York River State Park, club meeting the following month, and Night Watch, Corn Watch. So any questions about the events coming up?
You probably should cover October. We just go start.
We don't have time.
Yeah, but we're time limited tonight.
Oh,
But yeah, there is some good stuff in October too. All right, I'm going to stop share and turn it over back to the president.
Okay, real quick, Rich, give us a really quick treasurer's report to say we got money.
Yeah, I won't even bring it up actually. We have that's over $11,000 in the treasury. That was an increase of 268 dollars over the last month, mainly because we're starting to get East Coast Star Party registrations in. So we've had 7 registrations, $550 have come in for that. And then of that, we paid out insurance. We had 6 new members last month. So that puts us up at 196. And since the beginning of September, we've already gotten like 3 or 4 new ones in September. So we should be at over 200 now. That's treasurer.
Okay, do we have a motion to accept the treasurer's report?
Move.
Moved and seconded. All in favor, say aye. Aye. Opposed, nay. Accepted. We're going to waive the meeting minutes and old business and new business.
Audrey had a question. She's in the chat about, she's a member of the rec center. Can she attend the Astronomy 101?
Oh, of course. Yes, anybody can attend Astronomy 101. Just show up. If you're a member of the club, especially, you get in free. I think they charge a nominal $5, but don't worry about it. Okay, we are running low on time. I want to give Bruce a whole full 15 minutes because at 8 o'clock, we're going to start Rich's presentation about T. Corona Borealis. So Bruce, all yours.
Yes. Forgot about that. Great. Get up here, Jeff. I was getting comfortable. No.
So our esteemed vice president has earned the Solar Eclipse Gold Award. Okay. It is. It has a solar eclipse on it. I told him it looks like the eye of Sauron. So I think he's going to take over Middle Earth now. But so Jeff put in a large amount of effort for this. He made basically a wooden device of his own design to be able to look at the oscillations of the moon around the ecliptic over a period of 6 months, about 100 hours conservatively is the time he collected data. And then he also spent another 300 hours. This is always how it works. 3 times the amount of time that you spent collecting the data, analyzing it. Okay. And he was able to calculate the entire Saros cycle, if you're familiar with how eclipses propagate over time. Okay. So this is I note in the Observer, the Astronomical League magazine, there's a large number of silver awards, okay, that people were able to earn and receive. But Jeff has gone above and beyond in the calculation of the events for the eclipse. So I want to congratulate Jeff. Thank you very much. I also want to re-recognize Mr. Jeff Thornton, who also earned a outreach award. Okay. So all of those are in the Reflector magazine for you to check out. Okay. So let me see where are my pitches.
Come on in.
Did you share your screen in Zoom?
Copy. Okay. Okay. So tonight I'm here to speak to you about something I've already talked about with George and our esteemed secretary. They do not plan on running this fall. So I've been a member of this club since 2011 for 13 years. And this is my proposal for a officer transition plan. Okay. All right. So the purpose of what I'm talking about tonight is I want to generate more interest for potential candidates for the officer positions in advance of November. Okay.
Yes.
So the idea here is to get more nominations. What I've observed over the past 13 years is we tend to have a lot of what I call volunteering by extortion. Okay. But you want to be treasurer, right? Well, I don't know what the treasurer, what does the treasurer do? That's how Bruce Powers ended up being treasurer for 2 years. Okay, I don't want this pattern to repeat. Okay. What I'd like to do is assure that potential officer candidates that you have mentorship, 2 months prior and 2 months after, possibly more. Okay, so that we can get out of this habit pattern. Okay, like I said, we tend to put people on the spot in meetings in November election, and volunteering by extortion needs to end. I would like for it to end in 2024. Okay, why this is bad. So prior officers tend to get reelected to multiple terms, leading to officer burnout. Okay, we cannot depend on George Reynolds to run this club ad infinitum forever and ever and ever. Okay.
79.
Yes. So George's wife, okay, is going to come after us if he gets volunteered by extortion again. Okay. I watch it happen. Members are fearful of running for office. Okay. It disincentivizes people who are new to the club to participate. And really kind of, I haven't seen too much of this, but we have fewer innovations and less new ideas. Okay. And I've been in multiple organizations for a long time, and that leads to kind of a status quo. Okay. So I would like to see us get out of that. Okay. So my proposal is to advertise the 2 positions well in advance, understand tonight why volunteering is both personally rewarding and advantageous to the club. And like I said, offer mentorship 2 months prior and 2 months after, possibly longer. Okay, so why volunteer? Service and civic organization is a great resume builder. If you're a young person and you are looking to expand your resume, we've had some people come in and out of the club over time, and they've filled officer positions and they've been able to put it on their resume. Okay. You support citizen science efforts through public outreach. I mean, I would argue that amateur astronomy was probably the first citizen science effort to ever exist. But public outreach is what we do, and as an officer, you'll be plugged in directly to how that happens. Okay, you develop sought-after skills of leadership, public speaking, like me, and event coordination. Okay, event coordination is not trivial. All of this doesn't just magically happen out of the thin air. Okay. Jeff spends a lot of time talking to other organizations, and guess what? If you have a full-time job, 40 hours a week, you're probably in the need of these kinds of skills. Okay. One that's very important to me, as many decry the loss of civic organizations, officers become part of keeping a valued and long-standing organization viable for the future. So how long has this club been around? Since 1978. Okay. We always get a lot of participation. There's a lot of people that come here, but we're not up here, putting on a show forever. Okay. We want you and your ideas to get involved. Okay. So when I personally experienced, you develop a greater expertise and knowledge in the hobby of amateur astronomy. I've learned all kinds of new equipment. I bought another telescope, which I don't need, but I bought anyway because I'm excited about being in this club. Observing methods. I go to star parties. I bought a damn RV that I tow around because of the 4 telescopes I bought. Now 5. They're like rabbits in my garage. So so you're going to get plugged into lots of new techniques and events. Number 6, travel to and from meetings and official events is tax deductible. Okay, so George right here is Mr. Tax Deductible.
Log your hours on the Night Sky Network calendar.
Okay, all right. So if you're one of those crazy people that itemizes, good luck to you. Okay, you can put this on your tax return. Isn't that exciting? Okay, all right. And number 7, new personalities and leadership styles bring fresh ideas. It avoids organizational stagnation, which none of us like. We avoid losing members, and we help keep the club viable for the future. Okay. So next steps, the positions you can make a difference for coming up in November are president and secretary. Neither of these gentlemen plan on running again. Okay, that is the cold hard fact that's about to slam into us in November. But what I don't want to see is another volunteering by extortion event in November. Okay, I personally would like to see some perhaps younger people, perhaps some retired folks that have some more time on their hands than I do to help out. But these two people, okay, they need to go on to bigger and better things. And I don't want George Reynolds' wife coming after me. Okay. All right. So think, how could you make these positions your own and bring new ideas to the club? Okay. Talk to these two gentlemen tonight if you wish, and start your familiarization with what's going on. And decide to run in November to keep BBAA a great place to be for amateur astronomy. Okay. So I'm going to blast through these really fast, but basically the president duties as per the Constitution. At one point, we didn't have a Constitution, but now we do. Okay. So he's charged with the responsibility of assigning supervision of committees and appointed officer. I'm an appointed guy for the Alcor. Okay. You must be 20 years old. Okay. That's a little bit covered up there at the bottom in order to do basically any of these. Okay. Okay. The secretary, of course, keeps the minutes, which are important despite the fact that we waive them sometimes because it's a record of what we do in the club. Again, you got to be 20 years of age. Treasurer, Rich Roberts has performed fantastically in keeping all of our pennies in line for at least, 2 years now, Rich?
4 years.
All right, 4 years. Okay, you got me beat. But as you've already observed, we have a large budget for this club, money going in and out, and it's important that we keep track of that. You have to be 21 to be treasurer. And last but definitely not least, the vice president, as you've already seen, is in charge of public outreach. So president and vice president are not up for election, but the president and secretary are. Okay, so if anybody has any desire to relive this fine presentation along with the officer position descriptions, I have these up here for you to take on your way out. Be brief, be bold, and be gone, and I'm gone. Thank you.
Is there any thought of forming a nominating committee? Someone who wrangles people, because everything that Bruce said is spot on, especially about I've seen meetings, the November meeting where we're calling random people like, hey, will you be president? And they're like, no, can't get the next. We should do that in advance. Have maybe a committee or someone looking into trying to find these people.
Do we have any volunteers who would like to be on a nominating committee?
The best people are the people currently in the position. It should probably be the officers or someone else, but yeah, find your replacement.
I think I nominate Kent Blackwell.
It was just in the thing. The president appoints committees. George has the power.
I appoint committees.
Yeah.
Well, okay, we will get to. I'll do this a little bit later outside the meeting, and we'll get some people together to do an appointing or a nominating committee. Okay. Screen sharing has stopped as the share window has closed. Let's get rid of that. Okay. Our special tonight is a special presentation by Rich Roberts, who is a variable star expert. He's going to talk about T Corona Borealis, the star that will soon go nova. So, Rich, you're going to show us how to find it and what to expect. All yours.
Well, you already showed us how to find it in probably more detail than I will go into, because I think most of the people in this crowd can find Corona Borealis. But yeah, thanks for the introduction. It's going to say most of y'all probably know me and been treasurer of the club, but I am also a member of the American Association of Variable Star Observers, have been for several years. And for many years, I led the long period variable observing section. I had to give that up to your kids, man. They soak up so much of your time. I had to scale back in some things. So I'm flattered to be called a variable expert. I do know a lot. probably not an expert in my main focus that I know the most about is long period variables. And this is not one, but I do know a lot about this star because it's a fascinating star. And two, we are on the precipice of being able to see something that really you get to see once in a lifetime. The last time this star erupted was 1946. So there's not many people around, besides like Kent Blackwell, who remember that and were able to see it. But fortunately for Kent, he's probably going to be around for the next one. I don't know about the rest of us, but he keeps up. But as George showed earlier, we all know the crown. I always think it looks more like a ring to me. But off to the west, right off of Epsilon Corbor, is this 10th magnitude star, and that otherwise is pretty nondescript. You can't see the naked eye, but any day now, it's going to rival Alphecca. It'll become a second magnitude star that none of us will be able to miss. So we're going to talk about why that is, and also because this star is very unique. There's a lot of questions that need to be answered that we just there's a lot of mystery around it. And so hopefully we're going to get some of those answers. We're going to discuss what we're hoping to learn from this impending outburst, as well as there's a lot of as Bruce said, citizen science is a passion of mine, and astronomy is really the only place left where amateurs actually do regularly contribute to actual scientific discoveries. And they're going to play a pretty big role. A lot of amateurs are going to play a role in this outburst when it goes down. So we will move on to first, you just level set on some definitions, because we hear these terms like T Corbor is about to become a nova. Well, how's that different than a supernova or a dwarf nova? People use these terms that don't really know exactly what they mean. And on a fundamental level, you go, well, supernova is big boom, nova is medium boom, and dwarf nova, that's got to be a small boom, right? And functionally, yes, there is truth to that. Dwarf, there is a level of degrees. I mean, supernovae will increase in brightness by 20 magnitudes or more. Novae tend to be 6 to 10 magnitudes, and dwarf novae tend to be like 3 or 4 magnitude in outburst over their quiescent state. But that's not really what defines them. And each of these things, a supernova, a novae, and a dwarf novae, there's something physically very different which is occurring in each of these three things. So a supernova comes from some sort of collapse event where an object can no longer hold itself up from gravity. It collapses in on itself, and you get a neutron star, a black hole, some kind of remnant like that. I won't go into too much detail. If you want to go back, I think, man, it was spring of 2020. You could probably find the presentation I gave on YouTube to this club on the stars that go boom, since these are the stars that go boom, in much more detail. So that's what's going on with the supernovae, and there's different types, which we'll go into. And then novae is different. Like, this is a binary pair. You have a white dwarf star is being orbited by a companion star, and matter is accreting from that companion star onto the white dwarf. That matter builds up, and all of a sudden it gets to a point where it can fuse, and you get a gigantic H bomb. I mean, we're talking an H, that's what it is. It's a hydrogen bomb. Same mechanics. The only thing is, we're talking about an H bomb that's like 30 solar masses in size. So big boom. Dwarf novae are similar to novae in that it's also a white dwarf. It's being orbited by a companion star, but you don't get these thermonuclear eruptions that happen on the surface. Really, without getting too technical in the Roche lobes, there's instability in the accretion disk, and those instabilities flare up at times, and that causes a brightening of the system, and that's the outburst. And there's a bunch of different types depending on the how the outburst looked. These are your huge enorm stars, SF Cygni stars, Z Andromedas, stuff like that. Now, when we talk about novae, because these systems are all similar, but there's slightly different dynamics. Now, with supernova, there's the type 2 supernovae, which is completely different than everything else we're talking about. That is a massive star that can no longer fuse, collapses in on itself, blows up. This is what's going to happen to like Betelgeuse. Hopefully soon. I want to see that blow up too. I look at Betelgeuse and it's like, blow up, man, blow up. Just like every night I've been looking up at Corridor going, blow up, man. I want to see it. There's another type of supernovae called type 1A supernovae. These sound similar. This is a white dwarf star. It's sucking matter off of a companion star, and it gets too big. The white dwarf exceeds what's known as the Chandrasekhar limit. Chandrasekhar was an Indian physicist who figured out back in the 20s that after 1.44 solar masses of white dwarf, it can no longer hold itself up against gravity anymore, and it collapses down into a neutron star, and it can give you a supernova. Now, the way that happens is debated. There's different camps, and this is where T. Core Bohr kind of cycles in, because there's a group of people who believe that novae, or specifically recurrent novae. See, there's novae and then there's recurrent novae. Novae are ones that we've seen outburst once. Recurrent novae are novae that we have seen outburst more than once. Now, there is a theory out there. A lot of people say, well, maybe that all novae are recurrent, but we don't have the records enough to see all the outbursts. Like, for example, in 2018, I observed a novae in Persei. It was now labeled B 792 Persei, and it novaed. It got up to like 7th magnitude. A lot of people started observing it. Then we traced back and go, oh, there was a 17th magnitude star there. So we saw this outburst in 2018. For all we know, it outbursted 500 years ago, 1,000 years ago. We never know, right? We got to wait, wherever, or it may never. We don't know. But recurrent novae, we've seen multiple outbursts. Like we have seen 2 of T. Core Bohr. We've seen multiple of RS Ophiuchi and Euscorpii and all these kind of stuff. Now, what's different about the recurrent novae, which may separate them from the novae that have only outburst once, is all the recurrent novae have very massive white dwarfs. And so the theory is maybe that's what's triggering these multiple outbursts that we see, is because they're just so massive that they outburst more. And eventually, if mass is gained on that white dwarf over time, it could get to the Chandrasekhar limit, and then it would type 1A supernovae. So that's one camp. The other camp is it has to be 2 white dwarfs that spiral in on each other, and I tend to lean more into that camp. But we're not sure. It's up for debate, and each camp has reasonable arguments. So we study these novas because that is a question we're trying to answer. Or what is the progenitor for these type 1A supernovae? Because type 1 supernovae are incredibly important. We use them they're a standard candle that we can use to measure distance to things, for distance galaxies and stuff. So the study of them is important. I probably talked about this more than I wanted to. So let's move on to T. Core Bohr. And generally, when you look at any sort of variable star, the first thing you're going to go to is the light curve. And so here's all the data we have on T. Core Bohr, which goes back, almost 130, 140, a lot of years. And so what a light curve is a measure of brightness, or a star's magnitude, over time. And so you go left to right, you go back to 1860s and then to present day. The colors, because this is not visual observations, this is all photometry. So I know I've talked before about photometric systems. I'm not going to go into that now, but the green dots are Johnson V data. That's the passband that centered kind of around green. They call it the V band because Johnson was trying to mimic human eye response, which doesn't quite, but it's close. And then the blue dots are Johnson B, which is more to the blue. So those are the blue dots, and we'll get into the relevance later. But just from you can kind of go through the history of the star by looking at this. For once, before 1866, nobody really paid this star any attention. All of a sudden, one night in 1866, there were three independent discoverers said, "Oh wow, there's this really bright star now in Corona Borealis," and most people just assumed it was a supernova. Supernova had been seen before a couple times. We didn't really have the concept of a nova yet. RS Ophiuchi and Euskirpii were known, but they weren't known that this is what they were. They were kind of dwarfed in more with the dwarf novae, which had been around for a while. So, one of the stories from the Independent Brittingham is usually given the most credit, but there's another guy named Schmidt who reported the outburst. He was observing in Corona Borealis, and it was like nothing was out of the ordinary. He shifts over and starts observing, somewhere else, in like Pilates or something. This is what I do every now and then, like pull away from the eyepiece just to kind of take it all in and revel in the beauty of the night sky. And he goes, "Wait a minute, what's that over there?" It was this bright new star in Corbohr. It was T Corbohr. So people started watching this, after it got reported, like, hey, there's this new star. People thought it was a supernova, but it dimmed really quickly. Typically, to drop like 3 or 4 magnitudes for a supernova, that can last like weeks, like maybe a month. So T Corbohr, it dims much faster than that. It drops 3 magnitudes in like 6 days. And so it got to second magnitude, started dropping like a rock. And then all of a sudden, people noticed that when it hit 10th magnitude, it just stayed there. And they're like, what's going on? Because in, supernova explosions, the remnant is a neutron star or a black hole. It's not something you can just see. It doesn't look like a star, and there's diffuse, because of the stuff going out. And so it was weird. And so people were watching this thing. They're like, there's still the star there. What's going on? There's no remnant. And well, over time, people, as you can see here with the photometry and the thick green line, there was a lot of observations that width is because this is a binary. So there is an orbital period. It does dip up and down. And then over time, you got to the beginning of the 20th century, and at first people saw it and they're like, well, it's going to happen again. They had no idea what the period was. It had only been seen once. And so they thought it was going to go again. People were watching it. But over time, interest wanes and it kind of got forgotten about. Then the ABSO gets founded in 1911, starts contacting amateurs and say, hey, these are targets we want people to look at. And they put this one on the list. And again, it wasn't super popular, but fortunately for us, there was one man by the name of Leslie Peltier, very well-known amateur astronomer. He's written books and all this kind of stuff. He took Corbohr on, and he observed it religiously for decades. Like every observable night, he logged an observation on this star. And if you look at the photometry, you can see around this time frame in the 20s and 30s and stuff, it started to dip. Now, in 1945, Peltier put out what was equivalent today of an ATEL or an astronomer telegram saying, hey, everybody, start looking at T Corbohr, something's going on. He did that because he noticed that the magnitude of the star started to dip. It got dimmer. And he thought, or he assumed correctly, that meant that an outburst was imminent. Now, the weird thing about this is we don't know why T Corbohr does this. This is the only nova that does it. But there's this dip, and he saw it in 1945 and alerted all the other astronomers, and people started observing it again. And fortunately for that, we caught the 1946 outburst and got a lot of data on it. And then since then, it's been a pretty regularly observed star. You look at the AVSO database right now, there's 380,000 plus observations of this star. So it's well covered. So if you step back and look at some of the history, what else can we learn from this? Light curves can also be used to make predictions. So the first one, the easiest one to make, if you look at it, okay, there was an outburst in 1946. Outburst in 1866, outburst in 1946. When do you think the next one's going to be? They're 80 years apart. It's got to be 2026, right? Well, we do know that novas don't stick to a strict schedule, so probably around there, but this is the best you got. But there's weird things about the star that we can use to make better predictions, which is why we're here today. So when you go to the Johnson V data in these green dots, you can kind of see after the eruption, it didn't quite go all the way down. It kind of stayed in this higher state and then dropped to its quiescent state. And then about 10 years before the 46 outburst, it went up again. And then it kind of came back down slowly about a decade later. We call this is known as the high state. And we don't know why it does this, but more pronounced besides the Johnson V data, you can see from here, because after the 46 outburst, you see there's a lot more blue measurements than there are in V measurements. The blue measurements are because after the outburst, people wanted to learn more about the star. Fortunately, they went to the Harvard, the famed glass plates at Harvard College Observatory, which are all cataloged and just sitting there in their archive. And so people went back, pulled the plates that had core bore and found T on there, and started taking measurements off those plates of the star and then archived them into the database. So we can see what's going on. That's why we have a lot more blue data. The photometric system that they used was way more sensitive than blue and more relevant, and that's where it measured. But if you look at the blue data prior to the outburst, you can see this real sharp increase. So V or green, we'll say green, make it easier, went up a little bit. Blue went up a lot. What does that tell you? Now, in astronomers, we use the word magnitude. That's really just energy flux through a filter. When we talk about colors, and that's usually what tells us the most physically about the stars and the systems, those are the difference between two filters. So we have one passband, the Johnson V passband, and we have another one, Johnson B. And the color of all colors is B minus V. That tells you basically the temperature. So what it tells you now that B or blue light increased more than V light in magnitude, and that went down. So that means that the spectrum of the star shifted to the blue and that the temperature increased. So there's more energy now in the system. And this happened about a decade before and a decade after. Why, we don't know. It just happens. It only happens in the star. No other nova does this. But that's important because when you get to, like I said, based on the outburst, you say 2016 has got to be the time when it goes. The star re-entered this high state where V magnitude jumped about half a magnitude, and then it went up more than a magnitude in B. We saw this again in 2015. So if you go to like Sinbad and start looking at like papers on this, like a flood of papers came out in 2017, 2018, after people had time to digest this and look at this, and they're like, man. And then so new predictions came out saying, the star is going to nova in 2015 based on seeing this high state and comparing it to what the high state looked like back starting in 2035, right before the or 36, right before the 46 outburst. So there's unusual stuff going on, but it helps us with the prediction. Furthermore, why we're even moving that up even more, when I mentioned that about a year before the nova, Peltier noticed this pre-eruption dip that we can't explain. We started seeing that in the spring of 2023. So that's what people started doing models on that and said, no, this thing's probably going to go closer to 2024, in the window we're on now, the prediction was May to September. So we're in that window. So if we nail down this even more, you can drill down and look at the individual eruptions. So this is also kind of unique. So what I have plotted up here in the top left, that is each eruption in the band. We didn't have blue in 1866. We had V and B in 1946. But what's interesting is the eruptions from each of them were, this is time, 0 time is when the eruption happened, and then the days passed for each one. They fall right on top of each other. So it's telling you that when it's an outburst, T Corbor behaves exactly the same. That in itself is odd, but it does. So that tells you when you see stuff that it's predictive. The other thing is weird, and you go out a few more days, at about 100 days after the eruption, it has a secondary eruption that falls off, kind of lumps, and in 100 days it goes back down. We don't see that with any other nova, and no one knows why it's doing this, and no one's been able to figure it out. So hopefully we're going to get some more information and some more data, we can figure this out. The other thing to notice about the eruptive, like I mentioned before, is a very fast nova. They actually classify novas as fast novas and slow ones, and this is a fast one, but it peaks at second magnitude. It hits second magnitude, but it's below naked eye visibility within 5 to 6 days. It hits 6 magnitude. It drops that fast. So when we see it in the sky, and we'll be able to see it naked eye, it's not going to last very long. Hopefully we have some clear nights. And here's the pre-eruption dip that I mentioned before. This is the 45 dip. But if you look at it right now, it looks exactly like this, and people have modeled it out to try to predict when it's going to happen. And the answer is like now. Another thing I'll talk about real briefly is that's weird with the star is the orbital change. Like, again, this is an eclipsing binary star. It's a white dwarf and a red giant star. And from 1867 to 1946, there was no real period change. Then the eruption happened in 1946, and there was a substantial period change that occurred during the eruption, which was odd. I mean, that's not odd. That happens usually during eruptions, but what's odd is the change was so much that we cannot explain it through any known theory. So we just know it happened, and we can't explain why it happened to the degree that it happened. Since then, the period has been steadily decreasing, which means that the stars are getting closer together. This, again, is not odd. It's happening at a rate which we can't quite explain. So that's one thing that they're really going to be looking at post this eruption. Are we going to have another one of these massive period changes when the eruption happened? And what's it going to do after that? And that will help us model what's going on in the system, and then start answering some of those questions of, like, can this be a type 1A supernova generator? So yeah, I know I covered a lot. There's a lot going on in little time. And so just to kind of summarize the things that we're going to try to learn with this outburst, we want to understand the nature of this high state before and after the eruption. No other star does this. The pre-eruption dip, the secondary eruption. Again, these are questions because other stars they don't do this. So why is T Corbor doing it? A lot of those answers are going to be made with photometry, and a lot of it's being done by amateurs. Okay, soon as this star gets novas, or it erupts, every instrument on Earth is going to be pointing at it. There are targets of opportunity with JWST, HST, SPIDER. All these guys are going to be pointing right at it. Well, that's good around the eruption, but you have to have baselines around it. And all that data is being collected by amateurs. And it's happening now if you go in the database. And not just, kind of the standard filters of J and B, but amateurs are collecting data in J and H bands. If you have an Optec SS4 photometry, that's mid-infrared. That's going to help understand the dust. People are collecting U-band, which is going to talk about extinction, and things like that. So these are important data is being collected by amateurs that will be used by professionals to answer these questions. The other one is going to be the mechanism behind the orbital period change that currently we have no existing theory to explain. When it comes to will T Core Boar become a Type 1a supernova, one way to answer that is the question of, is this a neon nova? There's some evidence to say that it probably is. What I mean by that is, as I mentioned before, when I talked about the recurrent novae, those are all the ones that have really high mass white dwarf stars. Most white dwarf, 80% of white dwarfs are just carbon and oxygen because they're the inert cores of lower mass stars. Now, there's a kind of transition between low mass stars to just become carbon, oxygen, and white dwarfs before you get to the really big stars like Betelgeuse that go Type 2 supernovae. These are stars that may fuse some heavier elements. They can carbon fuse and oxygen fuse, and they produce different types of material like neon and manganese and stuff like that. And they have these different composition of white dwarfs. And so people tell me I can explain why. I don't understand why. I haven't researched it. People say if it's a neon white dwarf, it cannot become a supernova. I've just taken people's word for that. I haven't understood why that's the case. But the way we'll detect that is through the spectrum, because the neon emission lines are they're strong in the ultraviolet. It's like 3,800 and 3,900 angstroms. And amateurs have equipment that can do that, and they will do that. And this question will be answered. Well, I said there is some evidence to support. In the 1946 eruption, there was one paper who did spectrum in the ultraviolet. They saw neon emission, but it wasn't quite enough for us to say definitively because there was issues with the detection method. It wasn't flex calibrated, so they're like, yeah, maybe, but it's still not enough to definitively say, yeah, it is. That will be answered this time around because of just the equipment, and people are going to be looking for it. So if it's not a neon nova, and two, if this question comes back that T Core Boar is a neon nova, that doesn't mean that all recurrent nova cannot become supernova, Type 1 supernova. It means T Core Boar cannot become a Type 1a supernova. Others still may be able to if they have different composition, different types of white dwarfs. So if it's not a neon nova, we're going to be looking at things like, does the white dwarf itself gain mass or lose mass after the eruption? That can give us indicators of whether the other recurrent novae may able to gain more and more mass enough to reach the Shane-Shekar limit and become Type 1 supernova. If they can't, or if they lose mass of these things, that probably tells you that most recurrent novae probably will never become, these nova explosions probably prohibit them from ever reaching it. And the ones that do nova become Type 1a supernovas probably don't have nova outbursts. They just gain mass and get to that point and collapse down on themselves. All right. So there's all the science stuff. I know I covered a lot, so hopefully we have time for questions. I was trying to blow through this. Switching gears completely, we'll talk a little bit about some of the history of the star real quick. And so we had, we have the two outbursts, 1866, 1946. So there's Dr. Schaefer at LSU. One thing, it must be like a hobby of his, because I've read several of his papers, like on Betelgeuse, where he goes back and finds historical records. Like I was reading a Betelgeuse thing, he's talking about how Aboriginal tribes figured out the variability centuries before Western science realized that it's variable. Same with Antares, stuff like that. So he wanted to see if there was other records of TCRB outbursts. And the first one he found, you go 80 years back in around that time to see if you can find records. So there was this amateur astronomer, Francis Wallenstein, who worked with Herschel. And, back in the late 18th century, star catalogs was big business because it was so crucial for navigation. So he was making a star catalog, and he was making very precise astrometric measurements. And if you look at his star log, lo and behold, he has an entry at the exact coordinates of T Corbor. He took 4 measurements around December 1787. There was no apparent motion, so it kind of rules out asteroid or comet. There's no other remnants in that area, and its limiting magnitude is 7.8. So that tells you that, for once, this dude was legit. He didn't make an error big enough to be another star. He just didn't make those kind of mistakes, and it had to be an outburst because it's above the quiescent state, because normally this is a 10th magnitude star, but he records a star there. So it had to have been brighter than 7.8, which is amazing because remember what I said? The star, when it outbursts, is only that bright for like 6-7 days. So he caught it right at the right time, but had an entry there. So I think it's not an official outburst, but I'm saying it's pretty darn likely that that's exactly what it was. Is he just made his measurements right at the right time? And sometimes you get lucky, man. Sometimes you hit the lotto, right? Another one I find even more fascinating that Dr. Schaefer was able to dig up was Abbot Burchard of Erstburg. So this abbot was a very learned man. He, as a monk, he chronicled things that went around Erstburg, which I Google mapped. It's in southern Germany, kind of around Munich, between Munich and Stuttgart. In his chronicle that he published in 1225, he notes that in the autumn of 1217, he saw a new star in Cora Borealis, right? So again, you go back to the likely suspect of what he may have seen is the first thing that pops into the mind is comet. I mean, we know it wasn't a supernova because we would see a remnant, and there's no remnant in Cora Borealis. So he sees this object appear in the sky, which he describes as a stella, which is what they use to describe the point source. And he said it stayed with them for about a week, which is how long T Corbor stays above naked eye visibility. He also stated that it was a miraculous event and it was a wonderful omen. Well, comets were considered bad omens. And you read his other writings, he talks about, comets are harbingers of famine and plagues and all this bad stuff. If he saw a comet, again, he's not describing it as a diffuse object, not with a tail. He describes comets elsewhere. He says this is a stella and it's a wonderful omen. It's a miracle. I think it's got to be Corbor. I mean, T Corbor. That's probably what it was. I mean, yeah, Wallenstein. I will say with beyond a reasonable doubt, the abbot. I'm going to say beyond based on the preponderance of the evidence, it probably was TCRB in outburst, which is incredible, man. I think this monk was probably how he describes it when you read the translation of the text. It looks like he was actually looking at the sky in that direction when it was popped up, and he thought it was amazing. So I just think that's really cool. So moving on, I wanted to do a practical exercise since Jeff sent me a picture of T Corbor that he took with a sea star, which is right here. This is this red one. So I'm going to walk through, say if you had a ABSO chart and you wanted to do a visual magnitude, you wanted to estimate the magnitude, this is how you would do it. First, you got to locate the star. It's easier that this is a red giant. The companion's a red giant because often I look at long period variables, which are very red stars. I'll be looking like, which one's the star? I'm like, oh yeah, duh, it's the red one. But you print out a chart. I had to look up the characteristics of the sea star to get the right chart. So I looked up that the field of view is about 42 arc minutes left or right, and then the length is almost a degree. So it's not exact since I can't. CCDs are rectangular and these are made for eyepieces, which are circular. But anyway, I figured out through force what the orientation of north, east, and west was. and able to start comparing the charts and said, okay, here are the comp stars that are living on the chart. The target here is T-core bore, and I color coded the comps that are on this chart. So if you wanted to do an estimate, you would look at, first you can write off, like look at the yellow one and the blue one and go, okay, it's much brighter than that. It's much brighter than that. It's not even, so it's much brighter than 12, much brighter than 11.2. 10.6, this red one. It's close, but T-core bore is brighter. It's brighter than 10.6. The green is the 9.8. They're pretty darn close. I think T-core bore might be a pinch brighter, so I would probably call this 9.8, 9.7 if I was at my eyepiece and was going to record a visual estimate on this star. Now, I do know I would like to have a brighter comparison, something around like 9.5, 9.6. If I could, I do know if I had a bigger field of view, CCDs or small field of view, if I got out to about 1.5 degrees, I would get those comps that I really want. But that's kind of the process as you go through, and then you can go log in entry. And that's really all I had. I know I blew through a lot. I was hoping to leave some time for questions. No, where did everything go?
So do we have any questions?
Well, I was curious about the red giant. Since it's losing mass every 80 years, is it going to deteriorate and become something else besides the red giant? Is it going to die earlier or something like that?
So the red giant, yes. The red giant is going to the red giant, red giant stars are evolved stars. They're getting to the last bit of their life, right? And so that's when I talk about the progenitors of type 1A supernovae, it's not far-fetched to say
what I do?
What's that?
Oh,
It's not far-fetched to say that what actually is the progenitor are two white dwarfs.
what's going on?
It keeps changing speakers on you. I don't know.
I don't know what I did.
Can you hear us, Rich?
Yeah, I can hear you. Can you hear me?
Yeah.
Yeah, you're dropping out.
Hit F11 on the keyboard.
Okay.
F11.
I hear you guys fine. So it's a me problem?
The computer trying to full screen. I think it's fine.
Okay. Well, anyway, so what I was saying, yes, that red dwarf, that red giant star is going to evolve into a white dwarf itself. And so that's why that scenario for type 1A supernova progenitor of two white dwarfs spiraling into each other is actually very likely, because a lot of 80% of stars are low mass white dwarfs, and that's really what they come down to. Did I answer the question, Jeff, or do you got some more on that?
That's a good answer, actually.
Yeah. What else you got? I can't see you, so you're gonna have to shoot up at me.
I got two questions, if you could, Richard. With the white the white dwarf neon stars, the degenerate matter on that significantly different because the neon is a noble gas?
As I mentioned, I don't know why that a neon white dwarf, or actually it'd be a neon oxygen,
I'm just asking.
can't nova. I just don't know. I haven't researched it. I've just been told that, and I've been like, yeah, I trust you, bro. But I haven't done any verification, so I can't explain it. I've just been told that that's the case.
And you may not know this, so I might look it up differently, but do you know anything about the proposed orbital periods of the white dwarfs when they collide, if that's the method for type 1As?
Well, okay, so that's an interesting one. So one weird thing about T-core bore is the orbital period itself is so long. The orbital period of T-core bore is like 227 days. Most of the recurrent novas, the orbital period is like in hours. The only other exception is RS Ophiuchi, which is like 400 something days. And that kind of makes sense when you think about it, is for the star to accrete matter off of the companion, they got to be close. So if you have something with a 200 something day period, that ain't close. It's out there. And so it helps that the companion in this case is a red dwarf. And I think in RS Fuchsia, it also is a red giant star. And that's probably why. Because red giant stars, when they get evolved, they start having massive stellar winds. So they expel a lot of their mass out into the interstellar medium. So it's there to land on T Corps. But that also is because there's a class of dwarf novae called the Z Andromeda stars, and that's what they are. They're white dwarfs with a red giant companion. The thing about them is because the stellar winds off the red giants are so irregular, all the outbursts are completely irregular in time and in magnitude. So it's weird because with T Corps Bohr, as I showed in, I think this third or fourth slide, every eruption, now granted, we've only seen two, but those two track exactly. Everything about the star is very consistent in that the high state that we don't understand is consistent. The outburst is consistent. The secondary eruption is consistent. This pre-eruption dip is consistent. So it doesn't make sense why it's so consistent when your companion is a red giant star, because the stellar wind, the mass loss of the thing is not consistent. I can tell you that for a fact. So it's weird. But if in this case, that red giant star does evolve, which it will eventually, into a white dwarf star, they are far out. So it's going to take a long, long time. We ain't going to for them to cycle in on each other. But if you look at the other recurrent novae out there, they are not far apart. So if the companion does evolve into a white dwarf, spiraling in on each other is not going to be, crazy. That will happen eventually. And I mean, we do have evidence. I don't know if we have white dwarf. I mean, a white dwarf, other than if that is the progenitor of type 1a supernovae, which we obviously see. I don't know how you can tell that up front. Like, I mean, finding a system of two white dwarf stars, that's an observational challenge. These things are exceedingly dim. The only reason that we know that the dwarf novae are there usually with white dwarfs is because, they're accreting matter and it's blowing up. And so that brightens the system. But we do have plenty of evidence of stellar remnants, specifically neutron stars spiraling in on each other. You usually detect that gravitationally. But so, I mean, if neutron stars can do it, and these are much rarer, because to have two neutron stars, that means you had a binary system of two very high mass stars. And high mass stars are very, most, I don't know the percentage, but it'd be less than 10% of stars are massive enough to get to that point. To have two of them in the system, yeah, that's rare, but we see it. I hope I probably went off on tangents too much on that one, but
That's right. Heather, during the first, let's say, 24 hours from the dim part to the outburst, were there any notes in those observations of what it looked like visually for the astronomers or for the public?
no, it just happens. Like, it's gonna happen like that. And like I said, Schmidt was he was observing stuff in Corona Borealis in 1866. Looked away, and then an hour later, looked back, and there it was. So, there's no indicator that. I mean, this pre-eruption dip is the best indicator that we have, and it's telling you got about a year, and we saw it start about a year, almost a year ago. So it's close. We know it's close, but it's going to do it when it wants to do it, and we know we're in the window, but we have no way of nailing it down any more than we already have. Funny story I mentioned on that. I didn't say in the presentation, but I mentioned Peltier, how he religiously observed the star for over 20 decades. because he was the one who believed that it would erupt again. And the night that it erupted in 1946, he slept in. He set his alarm to go out at 2:30 in the morning to go do his dawn variable observing. T. Corbor was on the list because he observed it every time he went out. He writes about this star extensively in his book, Starlight Nights. So 2:30 rings out. It's a February morning. It's cold outside. I think he lived in like Ohio, a farm in Midwest somewhere. It's cold, right? He said, "Screw it, man. Snooze. I'm going to bed." It erupted that night. He wrote in his book how he never really forgave the star for that. Like he mentions that like he takes responsibility. It was his moment of weakness, but he felt that the star could give him more consideration because he was such, they were companions for so long. And then he continued to observe the star, and he said that but he does it now with a wary eye, because there's no more warmth between them. It was like a business like he thought they were friends, but then it was just like strictly business after that. He could never really forgive it.
I highly recommend his book, Starlight Nights,
Yep.
by Leslie Peltier.
Yep.
I looked at that star on April 22nd, 2019. And that's an unusual star, more than twice the size of the sun, but 1,000 times more luminous, and it was quite bright at my 4-inch TMB refractor at using a 7mm Pentax. So I've seen it before.
Okay.
2019. I took a picture of it about 3 or 4 months ago of the whole constellation so that I could compare that picture when it blazes. I have no idea what the picture is. No idea.
Take another one.
Yeah.
Yeah. Do it. You better, if you want to get a before and after, you got to get it quick because.
Yeah, I've been told that.
Well, like you said, they did tell us, hey man, like May to end of September, so we're still in the window, but we're running out soon, and it may not do anything for a little longer. We don't know.
No.
Don't get snooze.
Just for fun, here's that stellarium again. If I can share it again.
Yeah, every night it's not cloudy, I go out and I stare at Corbor for 5-10 minutes until I get bored, like because I want to see it like right when it happens. Like I just imagine staring there and all of a sudden, boom, you just see it.
It's kind of far in the west now, isn't it?
Yeah.
Yeah. Well, that's the other reason I wanted to hurry up, because when they announced the window, I'm like, oh, perfect. It's going to be high in the sky, but we're kind of running out of it being the evening is pretty low already. So
Yeah, it's there in the west.
yeah.
Arcturus is getting low to the horizon, but here is the constellation, the Northern Crown. And here is Epsilon Corbor. And if we zoom in on that, if you can find Epsilon, you can star walk. If you can see these stars, just follow that path. And right here, looks like almost a mini dipper there. There's T Corona Borealis.
Yeah, I recognize those stars from the charts that I use for estimates. They kind of make a V around it. Those are all bright stars. They're all about the same magnitude. There's a bunch of 9th, 10th magnitude stars right around it. There's a couple close double stars too that help you kind of, and that was helping me when I took Jeff's picture to kind of orient which way northwest and east was.
Okay, and if the way you find Corona Borealis, find Arcturus.
Yeah.
Arcturus, and it's the constellation Boötes, which I call the ice cream cone. It goes out this way, looks like a scoop of ice cream on top, and off to the left of it, off to the east of it is Corona Borealis, and up here is Hercules. Okay, thank you very much, Rich.
Pleasure.
We have a few minutes left. Do we have any observing reports? Anything that you've seen interesting lately? Yes, Kent, of course.
I don't have an observing report, but if you all want to hang around afterwards for a few minutes, I'll show you something really unique. Does everybody know what stabilized binoculars are?
Oh, yeah.
Like Canon?
Image stabilized.
Canon invented these, right? Canon, really good binoculars. They didn't invent them. Fujinon did. And I have a pair of the first ones that Fujinon made. They take 6 AA batteries, and they weigh a ton, but they really work. They work better than the Canons. The Canons kind of shift the prisms, but this uses a real stabilization.
Are those as heavy as your
When it
Japanese
stabilizes,
binoculars?
you know, everything goes around like this.
Yeah.
You got to keep the bucket close at hand. Seasick. But, yeah, take a look at them before you leave. They're really neat.
Are those as heavy as your Japanese binoculars?
Yeah.
Kent has a pair of Japanese binoculars off a Japanese World War II battleship.
Yeah, and what's unique, there's a plate on these binoculars. And I took that plate off, and there was silica gel, you know what that is, right, the drying agent inside, and it was wrapped in a newspaper. And when I opened the newspaper, it was a picture of zero planes being manufactured. Wow. Isn't that neat, though? That's paper back in there.
And if ever anybody drives a Mitsubishi car or sees a Mitsubishi car, they made bombers during World War II for the Japanese, Mitsubishi bombers. Any other observing reports?
I saw the new sail that they launched last night.
Solar sail?
Yeah.
Oh, yeah.
Yeah.
Where's it launched from? Canaveral?
No, it was overseas, if I
Oh.
remember right, somewhere, but, and I could only see it, for, right at the zenith, it brightened up, it was like 1.8, I think, according to heavens above. It dimmed fairly quickly right after that, into like 2.2, and there was some high clouds, so you can see it right at the zenith.
Wow.
Night, though.
Cool.
Should be visible at 10 or 9 p.m. tonight.
Is it?
Okay, is it in orbit around the Earth or is it heading out into space?
No, it's orbiting there.
Yeah.
Okay,
It's twice as high as the ISS.
twice as high.
We've all shown Saturn to people, like 1,000 people, but nobody's seen the ring schedule. Not so many people as Jeff posted the other day on his weather report. A beautiful picture of Saturn.
Oh, that was nice.
Great job. So many thousands of people are looking at that. It's neat. I don't know, has anybody seen the rings lately?
They're edge on,
Yeah.
edge on, very thin.
So the last boardwalk we saw it.
Yeah, 6 months it'll be.
Yeah, we saw, at Northwest River Park, just looks like a line. You can't even see the rings.
There's still a line going through here. It's so nice and bright, right through there. And you see a shadow right up in here. And that's with a small telescope. I've seen it 4 times now, Julie. What's that tell you? Takes 15 years each time?
You've probably seen shadow transits of Jupiter. This is one of the few times when you can see shadow transits on Saturn, because the planets, or the moons are in the same orbit. So as soon as you can get edge on, you can start getting shadow transits.
Oh, yeah, wow.
So it's a rare time if you want to see a shadow transit on Saturn.
What's the weather forecast coming up, Jeff?
Clear, some rain for the weekend, but then clear into next week, and then after that, I don't know what's going on.
Okay, tell T. Corona Borealis not to erupt when it's raining.
Yeah. Right. Yeah.
Okay, is there anything else that we want to talk about?
Yeah.
Yes, Jeff.
I've got an 8-inch telescope that was donated to us, and some lucky guy in here is going to take it to my car. So, it's on a wedge. It's a Meade mid-passing ring. It's complete except for an eyepiece.
Wow.
It doesn't have an eyepiece, but it's got
I'll tell you the
everything
number
else.
one thing right
Follow me to the car and use that. It's me.
Hey, did everybody get a raffle or a door prize ticket?
I did not.
Hey, Jeff Edmondson needs one.
Sorry.
We're giving away the telescope and Judge Torrance.
Well, there's two prizes plus. the telescope.
Okay, where's my hat?
Ball.
Okay, actually,
There's two prizes.
Jeremy has given us a couple more prizes.
There's some more.
So we've got 4 prizes, couple of fancy shirts, XL and 2XL. So I hope you're big 2XL. I might just give these away to somebody.
Okay.
Because you might, some small person might get a 2XL. They can wear it as a nightshirt. Okay, we have a 9mm Apertura Plusle eyepiece. Nice high magnification eyepiece. If you have a 25 or a 15, this is a 9, give you a little bit higher power. So that will be the first thing we raffle off here. Pick a card, any card.
3671910. Oh, that's me.
Hey. Thornton gets the eyepiece.
Thank you, sir.
All right. And this is a laser collimator. Got batteries included. Oops, I just lost the batteries. Did have batteries included. Now we'll still have them. Okay. This is also Apertura, brand new, out of the box, laser collimator. Got a Dobsonian reflector. It's perfect for that. So 3 little button batteries. And Jeff, why don't you pick the winning ticket?
All right. Good one here. There it is.
Okay, the winner is 3671916.
That's me.
916. Come to the meeting. Okay, oh, I forgot about this. This is a battery pack. If you want to plug in your, you have a fan on your Dob or something that's powered by 8 AA batteries. Little thing we'll give away here. Pick one.
3671903.
903. 903. Might have been.
that was Bruce, actually.
Okay, pick another one. Bruce White. He left. Last 3.
3671904.
904.
Is that Jacob?
904. There you go. Okay, who wears XL? Extra large.
Got a champion on it.
These are champion shirts. You open it up and see. Who wears 2XL?
What's it, man? I wear a Von Eck shirt.
Okay, you can open that up and show us what it looks like, Jeremy.
Oh, that's nice. Nice.
Champion, yay! We are the champions. No time for losers, etc. Okay. Well, it is 9 o'clock, right on schedule. And September meeting is adjourned.